Hi everyone. So we are here to learn about vectors and their operations. This time I want to go directly into the content and want to keep the video sizes small. So let's talk about the vectors and their operations. Scalar is a quantity with magnitude only. Okay, so examples are like mass or temperature or time. But vectors are quantities which has magnitude and direction both. So something like force, a direction matters. Okay, the direction of maybe airflow, velocities or speed of a vehicle, the direction, the acceleration, same the direction of the acceleration. These are all important. Okay, so a vector can be represented in a two-dimensional plane as a arrow, where the length of the arrow is the magnitude of the vector, and what's the velocity, okay, and then the direction of the velocity. A vector is represented with a name, and on the top we sometimes put a small arrow or put a hat. Okay, so it's like a or a hat. So this is a vector here. So this one, this is the length of the vector. The blue line is the length, and the direction is shown by the arrow. So now we can do multiple operations using vectors. Okay, so we can do addition of vector, which is like tip to tail match. So let's say there are this is a vector A, and then this is a vector B. The vector B can be in any other place. So if we want to add two vectors, what we do, we bring B from some other place, just slide it. We have to make sure the direction remains same, the angle and everything remains same. We just slide it in such a way that we do a tip to tail match. Like the tail of B will be matched at the tip of A. Okay, and then the resultant will be the addition vector. It's called the resultant, or C is basically A plus B. All are vector, you can see. So how we find that? We find from the tail of A to the tip of B. This is the resultant vector C, which is A plus B. Okay, so this is one case. So another case is when the two vectors are in the same direction, pointing to the same direction. So what we do in that case? So A is pointing this way, B is also pointing this way. So C is the total of A and B, and this is the vector addition. This is showing that modulus of C, that means the magnitude of C, is nothing but addition of the magnitudes of A and B. Okay, so mod C equal to mod A and mod B. So that length will be added, this length plus this length, and the direction will be the same because they are pointing at the same direction. Okay, so now let's consider this is a situation where A and B are with an angle. Okay, so A is pointing this way and B is, so we have done a tip to tail match. You can see B we slid from some other place and just connected at the tip of A, and then B is pointing this, and this is the angle of 90 degree here, so that they are connected with the angle of 90 degree. So what we do, we are saying that the resultant in that case is, again, you see the tail of A to the tip of B, we match. This is the resultant vector, but the magnitude of this C vector will be found using Pythagoras' theorem. Okay, so it's a mod A square plus mod B square and square root of that. So then we'll find the magnitude of C. Okay, it's very simple. I want to keep it simple. Now, vector subtraction is another approach where it's still we do the tip to tail match, but what we do, if we want to, like here you see this part, we see A and B are added, so C equal to A plus B, like exactly we did there. But if we want to subtract B from A, what we do, we create a negative vector for B, which is like the the B this direction. So the magnitude will remain same, but the direction will be opposite. So B is now pointing at this direction, so we call it minus B, and then we match the tail of A with the tip of minus B. So this is C equal to A minus B. So this is the vector subtraction. Okay, so how I find minus B, I just multiply B with a scalar which is minus 1, and then we get a reversing of the direction, and this is C equal to A minus B. So this is vector subtraction. Now we'll see some examples of mathematically calculating them. Now we'll see mathematically an example of vector addition, vector subtraction, and also multiplying vector by a scalar. Okay, so addition, let's see two vectors, A, which has two components. So it's a vector has a x component and a y component in a two-dimensional plane. So this is represented as a 3, 1, means in a two-dimensional xy plane. This x is 3, y is 1. So this blue vector is the vector A. Okay, so now there's a vector B, which is minus 4 and 2. So minus 4 means on this side minus 1, 2, minus 3, minus 4, and then 2. So that is the y value is 2. So then this is b minus 4 and 2. So now when we add the two vectors, what we do, we just add the x components and the y components. You see 3 plus minus 4, which is minus 1, and 1 plus 2, which is 3. So this is the resultant vector minus 1 and 3. If you remember, so what we did in the graphically, we bring the vector b from some place and then add at the tip of the a. So a and b will be aligned like that, and the resultant vector will be c equal to a plus b. So mathematically now you see minus 1 and 3, I draw the resultant vector pointing to minus 1 and 3, which is a plus b, this black line. Now you see one thing, if we slide a gradually and touch it at the tip of b, so this dotted line is basically after a being slid up to here, okay? So then this is a plus b is nothing but the resultant of, you see, from the tail of b to the tip of a. So that is a plus b. Okay, so as you know that because it's an addition, so a plus b and b plus a will be the same result. But this will not be the same if it's a subtraction. If you see a minus b, now we did exactly same thing where a is the a minus b component wise, x component, we subtract 3 minus 4 and 1 minus 2. So that becomes this 7 and minus 1. Now I have drawn it again here. You see vector a is here, vector b is here, vector a minus b, which is 7 minus 1, will be here, okay? So now if you see, if you remember what we said, how it works, for b we need to take the minus b, which is the direction will be opposite, but the magnitude will be same. So here what we did, this is nothing but minus b. See the same, we slid b up to here, touch it here, and the direction was here. So now the direction will be opposite, and the a minus b will be from the the tail of a to the tail of b in this case. So this is a minus b, but I wanted to show you that b minus a will be opposite because there's a subtraction, and then b minus a will be minus 7 and 1 if we want to subtract a from b. So we'll take the opposite of a and slid it here, and then it will be basically the the minus 7 and 1. It will be just the opposite, the vector. So opposite to that red line, which is a minus b. Now I also want to show you one thing which is called multiplying by a scalar. So any vector can be multiplied by a scalar, like a is the vector. If I multiply with a scalar which is 3, so what will happen? Both the x and y components will be multiplied by the same scalar. So 3 times 3 is 9, 3 times 1 is 3. So in this case what will happen, this let's say this is the vector a. So here what will happen, this vector will kind of grow up to 9 and 3. See this 7, this 8, and this 9. Let's say up to here, and this is 3. So this will be the the multiplied 3a vector. Okay, thank you.